Hi, let's try to model another part, this one actually, from my 100 parts ordered by complexity, and by now we modeled the part 1, 2, 3 and 4. Here there are 99 because the first is outside of this square, this rectangle. Okay. This part is a half of a hinge, and we concentrate on its drawing, technical drawing, which is this. Okay. Having this drawing, we can start to model the part. We start by opening the template, metric, then XY plane, and now let's start. We start with creating this closed area or contour, which has a radius of 10, a radius of 2, a chamfer 2 at 45 degrees, and here are some interesting dimensions because of this point. Let's go further. So we start with a circle with radius. We choose radius instead of diameter because this is the actual dimension on the drawing. We don't create or calculate dimensions. We take them just as they are in the drawing. The radius is 10. Okay. Then we make this a little smaller, because when we move the cursor on horizontal, we have here the position, and the dimension is 64 millimeters. Oh yes, then we have here 66, so we have a space for all the drawing. We continue with a line starting from here to here, so and now we keep the left button pressed and we create an arc. Okay, like this, and we go to the tangent. Okay, trim. What trim? This is for trimming. Now escape, and we see that we can move the line. Oh, but we have to have this point on the same level horizontal with this one. Look to the drawing. Yes, this point is from here to here. From 5 to 7 is 2. Okay, good. This is why we use the constraint horizontal. Now we can put the dimension here, 2 millimeters, and dimension here 5 millimeters, you remember, and just look to the drawing. You see this 7 millimeters is the end point of the radius, and that point is on the same horizontal with the center of the radius 10 arc. Good. We use this by introducing another horizontal constraint, this one with this one, to be on the same level. We look here, we need to add 3 dimensions. Wow! Where are? What dimensions? We can use automatic dimensions and constraints to see where are that dimensions. Apply. Oh, the length, the angle, and another dimension here. 3 dimensions. Remove. We put 21 and 64, and we'll see what next. 74 from here to here, 64, and 21 from here to here, 21, and still remains 1 dimension needed. Which one? There is a mistake here. Apply. There is something. There are 2 lines, one over other. You see, I didn't finish here the line, so we use extend to fill the gap, and now it's fully constrained. We see here fully constrained, and we also see fully constrained when we move here. It appears fully constrained if it is fully constrained. You also see here a pin, which means the same thing. Now we have to extrude to obtain 46 and 5 millimeters. So we use the tool extrude symmetrically on what? 46.5. 46. We can write, because this is marked with a square black rectangle, with a black rectangle, we can write just now 46.5. I hope I didn't make a mistake. 46 and 0.5. Okay, now we look to this extrusion, yes, which starts from the level of this point or from the end of the radius 2. Okay, this means that we start a sketch here, and we need to project geometry of the line, this line, to end the extrusion on that line. Another thing we have to do is to select everything, all the lines here, and to make them constructive. Now we create a rectangle, we put the midpoint of this rectangle coincident, coincident, not on the same vertical, but coincident with this point, this very point. Good. What means this? It means that the rectangle is symmetrical. What dimensions we have? We have a dimension here 19, no, excuse me, this dimension we have to respect 36.8 and the radius 3. Okay, 38.8, 38.8, 38.8. I am 74 years old. I forgot everything. Okay, and we align, we make collinear this line with this line. Now we see here fully constrained. Oh, but we have to apply fillet of 3 between these two lines. Oh, wow, not good. Fillet here and here. Sometimes there is instability there, and you have to choose other way to make a fillet. No problem. Finish sketch, and this is what we have. Another extrude, but for cutting, cut all the way, this is through, yes, through all. Okay, it seems to be okay. Look to this and to our part. Now we go to this extrusion. We choose this plane for the sketching. So we have this situation, yes. We choose all the lines and we select all the lines and make them constructive. There is a possibility to create directly where is project objects as construction geometry, yes, and when you use the project geometry tool you find all of them constructive, but this is not used. If you want you can use it. Okay, we project, now we intently project as constructive this line and this line. Why? Because now we create another rectangle which is aligned on 3 ways. But firstly I have to align this with this, align this with this, and this with this line. And now is the moment to place one dimension, only one dimension. What dimension? The dimension is 19 plus 10. We don't calculate by head. 19 plus 10 is 39. Oh, 29. No. We put an expression here. From here to here, an expression. 10 plus 19. The result is made by computer. Finish the sketch. Extrude symmetrically, cutting all. Okay. I forgot radius here. No problem. We use fillet here of how much? 6 millimeters. We write 6, and before to end we choose the other edge. Okay, there is another radius here, 2, so we choose this and we choose fillet and 2, but also here. Okay, another thing is to put this 2 at 45 degrees chamfer, not fillet. By default it is just 2 millimeters. You see here, you see here. Okay, this is called mini toolbar and there are some tools which have both window and mini toolbar. You can choose either one to put dimensions and so on. Options. Okay. F6. I press F6 or I choose this. Is the same thing. Home. Good. Now all we have to add are these holes. Let's make them. This one with the radius 10, with the diameter 9.5. Radius 10 is here. Other thing, of course. For this is simple. We choose the tool, we activate the tool, but not so, and we have to select the plane, a plane. This is the plane, and because we want to be concentric this hole with the exterior, we choose the exterior and put, instead of 0.52, 9.5. Okay, and now there are two other holes. 34 distance, 9.5, like this, the same dimension, but they are very different. And on this face, good, we choose to make some marks here, 2 points in a sketch. We put them together using a line. Why? Because we constrain the line, and we find the point constraint. First vertical for that line. Good. And horizontal are this point with the origin, which is here. I know that this is here. If you don't, you choose the second point. That one is the same thing. Yes. And now the points are symmetrical, placed on this surface or outside the surface, of course. Put here the dimension 9.5, and here 34. Finish the sketch and apply hole. What dimension? Dimension is 5.2. Okay, you can write here 5.2, no problem, 5.2, but we go here to see what happens. Okay, 5.2. Good. F6 to place in a default position, isometrical position, and now we choose a material, steel carbon, semi-polished. No, we want to choose gun. Yes, gun metal, antique, polished. And to show which faces are machined, we choose an aspect. This is the aspect. This is the material, and this is the aspect. From T, titanium polished. This is my option. Now, because we have a part with material not generic, we can look to properties, update, and we see here mass and the volume. They are very important for you if you decide to make this part. You have to look here to see if it's identical or in a limit of error of you see here error is under 0.00%. It's very small error. This is a very small error. Close. That's all. Good luck and a happy new year 2020. Bye.